You are watching the 7.1 lesson video on absolute value functions. Now, in this unit, we are going to be revisiting like a lot of topics and I guess ideas that we discussed back in Unit 2. So like domain and range and all that stuff. And we're going to explore just different functions that we haven't really talked about yet. Some of them will be repetitive, but here's one of them that you may have talked about in Unit 2, but we're going to dig a little deeper. So the absolute value function. Now remember, the absolute value of something is the distance something is away from 0 on a number line. So for exercise 1a, we're supposed to simplify the absolute value of -7. And if we look on the number line, it's actually 7 spaces away from 0. So the distance a number is away from 0 on the number line, it's 7 spaces. Distances can never be negative. That's why when we take the absolute value of -2, it becomes positive, but the absolute value of 6 just stays 6. So it's always going to be positive. And of course, 0 is 0 spaces away from itself. All right, so we've already looked at the absolute value function back in Unit 2, but let's just dig a little bit deeper. So we're going to draw a picture of it, and we need to evaluate f of -7 and f of 4. So we're looking at our absolute value function here. So f of -7 is really equal to the absolute value of -7. We're just putting in -7. We're just substituting in -7 for x. Therefore, it's +7. And the same with f of 4. That's the absolute value of 4, which is +4. Now in B, we're going to fill out the table of values, and then we're going to graph it. It doesn't say to graph, but let's do it anyways. So the absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2, and so on and so forth. The same thing with the negatives. The absolute value of -1 is +1, +2, +3. We're just taking each one of these x values and substituting it right in there, so it makes it positive. Let's quickly graph it. And even though we don't have a table showing the points 4, 4, 5, 5, 6, 6, 7, 7, and so on and so forth, we can still do that. And then we'll plot the negative x values, but realize that it takes all of our negative y values and made them positive. That's where the v is coming from. So what is the minimum? Well, it's this lowest point here of our y's when y is equal to 0. And then it says over what domain is f of x increasing. So we want to look at where the graph is constantly increasing. We read a graph like we read a book, so all of this stuff over here, and that is when our x values are from 0 all the way to +infinity. So I could say over the domain x is bigger than 0. I could also write it as 0, +infinity. Either or. Inequality notation and interval notation down below. Okay, exercise 3. For the function f of x is equal to the absolute value of x minus 4 plus 7, which is the value of f of 1. So what we're going to do, well, we could graph it if we wanted to. I am going to substitute it in. Either way is fine. So using order of operations, we're going to simplify what's in the groupings first. So 1 minus 4 is -3 plus 7. And I'm just copying and pasting. Absolute value of -3 is +3. So 3 plus 7 is 10. So f of 1 is 10. Another way that we could look at this is that the point 1, 10 would fall on the graph of f of x. Okay, heading over to exercise 4, it says here to find the average rate of change over this domain from -2 to 7. For this function, the great news is they've already graphed it for us. But remember, the average rate of change is the slope between 2 points. And the way that I like to show it is make a table. You got it. So a table of x and y, or in this case f, or x and f of x. They told us our start and our finish of the x's, so -2 and 7. And then what we need to do is pull our y values from those. So let's head over to our graph. When x is -2, y is 1. When x is 7, y is 2. So technically, we are finding the slope of that line right there. My line's a little wobbly, but you get the picture. So you could, if you wanted to, calculate rise over run. So up 1 to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be 1/9. But let's also see how this looks in the table, because it should work out to be the same. So our y values increase by 1, and our x values increase by 9. So either way, no matter how you look at it, the slope between those 2 points over that interval is 1/9. Okay, exercise 5. So we need to describe how the function was transformed from the parent, and then label its max or min with coordinates. Then lastly, we need to come up with the equation. Okay, I'm going to do things a little bit out of order here. Let's go ahead and just label the maximum or minimums, the vertex. So here, this is a point -1, -2. Here, this is a point 3, 0, not 0, 3. 0, 3 is up here, remember that. And then here is a point, I guess I'll write it up here, 0, 5. So we have already done that piece. Now let's talk about how each was transformed from the parent. Now the parent function, remember, is what I'm just kind of sketching here in blue. I could do this with every single one of the graphs. In fact, I'm going to do that now. You might just want to put a few little dots on there just so you can see. Sometimes I'll put it in like a dashed line if you can't see the dots so easily. Go ahead and dash it. So what I mean by this is just something like that to help it stand out a little bit better so you can see how it's changed. So in A, it looks like our graph has moved left 1 and down 2. So if we write this as an equation, y is going to equal, well, we're going to set up our template here. And to show the left one, that should be x plus 1, and then down to -2. Remember, to check this, we should graph it. So every single one of these, when you're doing the practice, you're going to graph these to check them. All right, heading over to B. B, it looks like, we move to the right 3, but notice how my slope is steeper. So steeper by, it looks by 2, because instead of the being here, here, and here, we're noticing that it's growing at a slope of 2 over 1 instead of 1 over 1. Okay, so writing out our equation, y is equal to the absolute value of x. Well, steeper by 2 means we have a multiplier out in front by 2, and to the right 3 inside the parentheses, or in this case, inside the absolute value functions would be x minus 3. Okay, lastly, in C, what is going on here? Well, the vertex was moved up 5, but it also reflected over the x-axis. So when we write out our equation of this absolute value function, here's my template, the absolute value of x. So this one was shifted up 5, so plus 5, and reflected over the x-axis would be negative out in front. Remember, the parent function is just y equals the absolute value of x. So this is the inside of the function, This is the outside, and out in front here is going to give us either the wider, the more narrow, or the reflecting over the x-axis.